So I'd like to introduce Mike Dodds. I had the most lovely experience, which was with Matt Parkinson, Mike Dodds and myself, and Victor, wherever he is, and others, many others. We did work on the verification of concurrent programs in an academic setting. And since then, he's gone to Galois, learned lots, apparently, and we're going to hear about them. I introduced
allegedly learned things. Yeah. Well, you be the judge. Victor came up and said, "Is the value of n 0?" So I was like, "No, you'll find out. You'll find out." Yeah. So I was an academic, and then I wasn't an academic. So I used to be Matt and Peter's postdoc back in Cambridge, working on various concurrency verification things, and weak memory, like good kind of like core exciting PL things. And then in 2017, I joined Galois, and I'm a PI, principal scientist there. And I've done formal methods things of various kinds since. So parsers and crypto of 2 different kinds, and protocols and various other bits and bobs. And I don't know, probably Galois is pretty well known, but you know, we do research for cash. Not, you know, it's a bit more complicated than that, but it's sort of, that's the essence. We're sort of a contract research shop, essentially. Or I think people have called us an R&D temp agency. You know, we will work on your research task for money. And it's 110 people, employee owned. I will not gush boringly about how much I love Galois and how great I think everybody else there is. But like our background is really like security and reliability technologies. So kind of PL, formal methods, static analysis. And it's founded by a guy called John Loshbury, who was an early Haskell designer and very involved in the functional programming community, of course. And like the real, you know, really we're kind of, most of our funding comes from US government one way or another, DARPA, DOD type things. Some other US governments, like we've done things with the census, and we've done commercial things as well. We're doing some really interesting things. So we've got this thing called CN, which is Cambridge and UPenn and others. We're working on this project called Verse and helping them develop CN, which is this unified testing and verification tool. Talked about it this morning, and there'll be more things with Christopher later in the week. We built a language called Daedalus, which is a safe parsing language. I'll talk a bit later about that. We're currently working on C to Rust, which is a transpiler from C to Rust. It's well named. And we're working on a proposal for Tractor, if anyone's working on that, so I'm happy to share what I know. And we've done a lot of work on verified cryptography, including quite a long piece of work with Amazon Web Services, where we verified some bits of the AWS libcrypto library. And I won't talk about any of that stuff, sorry. But if you want to talk about any of this stuff, then come and talk to me. I mean, it's sort of all implicitly in this kind of, this talk as well, a little bit. So, okay, then what? I've done quite a lot of a kind of weird job, which I think is like a job that not a lot of other people have done, which is formal methods, technical sales, basically. So, you know, what happens is Galois does engagements for clients, and those clients might be government or commercial, and, you know, clients, you know, at an abstract level, what happens is the client calls up and says, I have heard of formal methods, I'm interested in doing a formal method. And I say, great, wonderful. And so I'm often the person who helps to try and scope a project. And so we sort of ask what they want, you know, objectives and target systems and teams, budgets, and all that kind of thing. And sometimes we have success and we scope a project. And then even if we're even more successful, then the client is happy at the end of that project. It does happen mostly. And sometimes it doesn't work. So we don't scope a project because the client doesn't want what we can do. And that's kind of the business of being a consultancy, is that you do a lot of that kind of like talking to early stage people. And so one of the things that I kind of think I could share with this community that I don't know if a lot of people do is like what the considerations are when you're trying to scope formal methods projects and actually do them in practice. So that's kind of what this talk is. It's like, you know, things I learned in 7 years of sales calls. So this is now a sales conference, which I hear are much more fun than formal methods conferences from my people, friends in sales. But, you know, we'll see what happens later on. here's a totally phony baloney, kind of horrible abstract view of the world. We've got a landscape of costs and benefits. On one hand, we have things with high benefits and low costs, and things with low costs and high benefits, and those kinds of things. And like costs, I sort of want you to think of like holistic cost, which is like time and money and people and resources, you know. And then we've got like holistic benefit, which is like security and reliability and economic value. If you want to use the word utility, you can, but I don't recommend it. And there's some sort of like client-specific break-even line here. And really all this picture of the world says is that if you get a choice between doing something that is beneficial and doesn't cost you much, and something that costs you a lot and isn't very beneficial, you probably should do the first one. And like that's kind of the way that everybody operates, really. They're making trade-offs between things that they could do. And I think that, like, okay, I'm not going to say the most controversial thing in this talk, which is, I think engineering teams are somewhat rational in terms of those kinds of trade-offs. So projects that make sense in terms of costs and benefits will occur, and projects that don't won't. So that's kind of like my worldview, and it kind of comes from, I don't think it's like, you know, it's under incentives, obviously. So what you care about may change depending on what your incentives are. So I think that now, to get a little more spicy, surprisingly many potential formal methods projects live in this region here, that doesn't make sense region. And so what happens is that those projects do not in fact occur. And I think it's, that means that, I think sometimes we talk about things that are like possible and impossible, but in fact what really is going on is that the thing doesn't pencil out, and so it doesn't occur, versus it makes sense and it does occur. So why? And what can we do about that?
Are you talking here about industrial projects or academic projects or both?
I'm talking about the entire universe of formal methods projects and all values things. So I'm attempting to abstract over that, which I realize in this audience.
Why do you not care that projects don't make sense?
Well, I mean, we're getting into deep waters here. You presumably have some utility function in your head which tells you whether something is good or not. I'm going to try and communicate what the clients we talk to care about and how they evaluate projects. But you may not agree, and in fact I think that this community does a lot of things for us more aesthetic than utility reasons, and that's fine, but it's not what our clients care about. So here's some hot takes. Projects have to deliver value early. Correctness often doesn't matter. I'll walk through all these. There's slides on all these. I'll talk about them later. But the cost-benefit trade-off is kind of the really core of it. So here's a big one, which I think actually matters. So I'm now going to plagiarize myself, and Benjamin plagiarized me earlier, so some of these slides will look very familiar. So here we've got a bad cost-benefit curve. And what happens here is that, like, for a long time, you do a lot of work, and you don't get a lot of benefit. And then at the end of this, you get loads of benefit, great. Now, what this describes is your classic interactive theorem proving project, where you spend a lot of time setting up initial definitions, you prove some lemmas, and then you prove the main theorem. Now, it's not to say that like there's no value in doing those initial definitions and whatever, but the value you get does not rise very quickly until you've proved the main theorem. You know, for all of these things, you know, we may dispute this later. And at this point, we've got high cost and low benefit, which is not very good. At this point, we've got high benefit, but it's very late and very expensive. And one thing to observe is that this does not work very well when you're trying to work with clients. So the client comes to you and says, hey, I'd like to do a proof with you. That sounds great. What value would I get in X months for Y dollars? And I think, oh, great. That is here, right? Now, what's going to happen is that I say to them, oh, hey, how about 4 times as many months and about 8 times as many dollars? And then they don't call me back. So this is not ideal.
Question?
Oh, go ahead.
We've heard a lot of people telling about the interest of specifications even before proofs. So I would expect the curve not to look like this, but to have a plateau if you do specifications and then other.
I, in fact, talk about that later in my talk, to some extent.
So it doesn't look like this, the curve.
Well, I think that this curve is quite, this sort of, if you look at it more holistically, I think that it's true that a lot of things have, in formal methods land, have like a high setup cost. And it takes a lot of time before you kind of get to the good stuff. And that could be writing specifications, it could be like understanding the code, And maybe I've even got a slide about that. Just 1 second and then ask the question again. Anyway, so ideally what you want with a project is you have a small cost and you have a small real benefit. Yeah, go ahead.
Just a thought, I mean, in other domains, like if I'm building a huge bridge across a river, I have the same kind of curve. So it's completely useless until I'm finished. But people still build.
Yeah, I mean, I think that Galois is operating in a particular environment where our funding comes out in sort of quite small quantums. But I think that also you can build quite a bad bridge before you build a good bridge. And like it was not like humans started out by building kind of the Golden Gate Bridge. They built more primitive structures. And so I think that all of those things were valuable when you built them. So I think it's kind of, I think there's some sort of, but you're right, I mean like capital infrastructure projects definitely are a thing. The governments can spend on these things, but you probably need to show some value of that thing before you do that thing.
Yeah, people have built many bridges before, so we know it. We don't expect at the end. It's not an answer.
I can see this is not going to get to all of my end values, which is why I thought I'd make sure the end was variable, you know. Anyway, so like the good thing about this kind of curve where you have some value is that then the client says to you, this is great, let's do another project. And then you do another project. Good, sales. Yeah, so now you've kind of, and so you really need to, but you know, like it's very often, we have had the conversation, I've had the conversation where the client says to us, we have X dollars, and I say, well, okay, that would basically get you nothing. And so then they sort of, we look at how much it would actually cost to do the thing they care about, and it costs way more to even get to the first unit of value. So this is like a lived experience that I have lived through. Okay, and like formal methods tools sort of don't really have this shape often. There are lots of things you have to do before you get to the benefits, like writing specifications, building proofs, understanding the domain, training engineers, those kinds of things. Like some of these things, we could imagine different tools that, and Benjamin and Peter and Christopher and Rini are working on very interesting things that might kind of bend these curves. But the state of what we have right now is this. For Galois. So like, you know, again, let's talk about testing. Everyone's like, oh, testing's so bad. Like the good thing about testing is you can write one test and a test is useful, right? And a test runs on the real system. And so, you know, write, test, debug, you write some code, you do some tests, you write your tests, you fix the problems, you write some more tests. That gives you this kind of, this is also, I think, explains why, you know, JavaScript or Python is so popular. You can just do something for like in 10 minutes, which is valuable. Now, okay, right, I hear you heckling, but it's difficult or impossible to achieve higher levels of correctness. Formal methods wins. Well, I don't think correctness matters that much in a lot of cases. So I, again, feel like maybe I'm saying the wrong thing in this audience, but like obviously at some margin, a piece of software being correct does matter, but like many systems, I'm telling you from talking to clients, have adequate mitigations. They have priced in the bugs. They don't care that the bugs are there. And the marginal value of fewer bugs or more security is often like nothing, really. They don't want it to be any more secure. It doesn't matter if it's more secure. And that's actually, to my sort of slight shock, is even true for high assurance things that have bugs. Yeah, very surprising to me. So, some things that, you know, this is me stealing Peter O'Hearn's opinions, really, but like correctness might be less important than other kinds of coding properties. So things like the ability to ship features or security fixes more rapidly, or the ability to hire a developer team, right? You know, a thing that people really care about, the thing we run into a lot is we build things in Haskell, and then people say, we can't hire a Haskell team. And so, well, that's like a really big problem. There's a limited number of Haskell people. There is a very small number of people who know how to drive Lean or Coq or whatever. Like paying down technical debt might be more important, or meeting upstream needs from customers, or reducing other kinds of costs. Now, this isn't so painful if the correctness technology doesn't cut against these other kinds of demands. So, for example, if your theorem proving system using that means you can't hire into the team, well, that's going to be very painful. If it means that, you know, there are formal methods projects which are great, but that have really struggled to kind of like move with new updates because the cost of maintaining the proofs is so high, those kinds of considerations are really important to people who are building real systems. And so if a correctness technology makes the above things more costly, it will be very costly. They will really consider that. So here's an anecdote, which is just in the last year, in fact. So we were talking to a leadership person and a high assurance developer, and one of my colleagues said something like, let's say we had a moderate cost tool that would make your system twice as secure or reliable. Would that be valuable to your business? And this person said, no. So again, you know, I feel a sort of visceral shock hearing somebody say this, because it's very against the kind of preconceptions I have as a formal methods person. You know, this is a thing which goes into a thing that does high assurance things, and we probably don't want it to go wrong. And they're saying be more secure does not help them.
How much of this is that actually high assurance developer, because they can't produce things reliably right first time, they have layer upon layer of safety net and caching?
I think that's a big factor, actually, yes. I think that the, so in fact, you're coming at my point, in fact. So the analysis of this is, well, their current reliability and security practice works well for them, and that's okay. They believe their system is already more reliable and secure than their competitors. Now, you don't have to be faster than the bear, you just have to be faster than your friend, to quote an anecdote. And you also, they don't feel like they win or lose sales on reliability or security considerations. So if they spend money, if anything that they do to make their security and reliability more costly, even if it's just like introducing a new tool, it has to meet a very high bar for them. Now, here's the kicker. What if we can make your regulatory compliance testing 10% cheaper? And the guy said, okay, that would be worth like X stupid millions a year, right? You know, this is like a highly valuable thing to them if we can make that cheaper. Now, we're talking about things in high assurance land where there is extensive testing. And so the analysis here is, without compliance testing, they can't sell the product. This is an actual driver of revenue. And so compliance testing is very expensive and it's highly manual. And it also slows down release schedules or reduces flexibility. It's very grinding for their engineering teams. And it's very hard to staff those teams. And so what that means is that, like, if we have tools that could like help with those kinds of problems, they are immediately compelling. Now, you know, under capitalism, we can sell them those tools. Those tools are worth actual money. So, yeah, real conversation we had. Now, I will say, and most, yeah, go ahead.
I read a paper once by, I think about ComCert, who did some effort to try and convince compliance regulators that ComCert is a useful thing for I think the airplane industry or something like that. And from what I remember from the paper is they had a lot of trouble trying to convince these people that what they were doing actually was worth something.
Well, there's an entire other talk about, you know, fun with regulators, you know, which I think is like, it's a very separate thing. But you're completely correct that you would think that regulatory compliance and, you know, security and ability to do formal methods were sort of the same thing, and it is absolutely not the same thing. Peter?
I want to observe that we had a great talk last week from Sam who explained the current distinctly less terrible than we had expected state of concert and certification.
Oh, wonderful.
They just translated it to French.
That was what was needed. It was just, if it was in French, then well, I guess that's, you know, that's what we should do as well.
So I have another thing, if I can interject. So
oh, please.
One line of motivation for this kind of work and our wonderful theories and tools is more correctness. But another different line of work that you've not, rather different line of motivation that you haven't really touched on, is just using these things to make normal engineering easier, which can happen. And it's not necessarily a cost center.
Yeah.
So Alistair with a D talked about some of the use of sail in the risk 5, but he didn't talk about the use of sail in the cherry development process, where normal engineers picked it up and liked it and got value from it and owned it kind of from the beginning, because they're trying to do a hard thing and it's actually easier to do the engineering.
Yeah. I mean, so I don't want to give the impression that like every project we did was a complete failure because of this. I'm trying to kind of like, you know, I should have added the I heart formal methods, and we actually do a lot of stuff at the start. And to your point, I think Rust is another good example of like PL world, verification world ideas making their way into the tool that people can use to build stuff. and then when they can build stuff, that is actually really compelling. It's in some ways like the division between the kind of, like you say, if we're a cost center rather than a revenue center, then we're always going to run into these kinds of dynamics, I think. It's very hard to sell any kind of testing tool. Anyway, so just to say, like, well, security bugs really matter, as everyone, I think, probably knows by now. Like, in lots of environments, non-security bugs are adequately controlled. They're not a big deal. But security bugs really matter because, like, a single bug can be a catastrophic failure. And a lot of our projects are motivated by a client that has a threat in mind, and they want to mitigate that threat. I think it's useful to understand the threat model, though. I think that's something that I don't know there's enough like research on. So, for example, in crypto land, it might be that memory safety violations are really bad because they mean that the host system can be compromised. But incorrect implementations of the primitive itself, in terms of like mangling the algorithm, firstly, that's easier to test for, but also it only compromises potentially a single message, and so maybe it's less bad, and maybe timing attacks, they're out of scope or mitigated by some other mechanisms. So I think that like having more work on like, you know, we're building a tool to address the following threat is probably an interesting thing to look into more. I wish I saw more of that kind of work in PL world. Okay, finally getting on to the topic of this workshop. Specifications don't exist, mostly. Well, I'll nuance this, but obviously, like what we want from a formal spec, ideally, is we want them to be mathematically clean and stable over time, agreed by users of the system and easy to reason about. And it is true that like there are kinds of systems where we have these properties. So cryptographic algorithms, operating systems and hypervisors, compilers and programming languages and hardware, asterisk, ignoring the whole weak memory hellmouth. These are the big success stories for formal methods, but I just sort of want to point out that like these are, you know, when you go out like talking to people about the same things they want to do, these are highly unusual properties for a system to have. Like, you know, we are picking the systems which specifically are well suited for formal specification. And even slightly less formalizable things, it becomes very difficult to deal with them because even the challenge of specifying them in a coherent way is very hard. Most systems, I would say, are very unformalizable. So here's another anecdote. Just, we did a lot of work on PDF. PDF is like a kind of threat to like systems because people receive PDFs, they have attacks in them, things like that. You can embed JavaScript in PDF for God knows what reason. And so PDF has lots of parsers, it has lots of use cases, it's got a vigorous standards body, the PDF Association, and it's got a large body of examples of the format. But what it doesn't have is agreement between the existing parsers, specifications that match the de facto behavior, or in fact, a clear definition of what a bad or insecure document is. And so one reason is that parsers are incentivized to parse bad documents. So that's because if you reject a document, then, and you know, probably what you say is, oh, my iPhone's busted, my laptop's busted. So they parse things. This means that there are many ambiguities in the actual use of this thing. Now, we have a giant, you know, called this the potato of doom, right, where you've got like kind of some known bad data set with about 1 million files, I think. We have some known bad examples, like things that are definitely kind of adversarial. We have some known good examples, which we think are kind of conformant to the standard. And most of these things, we just are like, well, we don't know. They might be wrong in various ways, but they're kind of out there. And there were nearly no documents that were actually 100% standards compliant. And so we spent quite a long time formalizing PDF in our fancy language called Daedalus. And we tested it on millions of cases and worked really closely with the PDF Association. But I mean, the reality is, like, PDF does not exist in some sense as a coherent, well-defined category. Like, the specification we wrote is non-descriptive. It's just different from the real parsers, and they don't want to become conformant to the specification. It's non-normative because it doesn't characterize the bugs. We don't know what the bugs, you know, we don't know what insecure behavior is. And it's very unclear for even something as formalizable as PDF how to get to a more rigorous and broadly accepted specification, because it's not really a thing like a hardware layer where you really have control over it in the same way. Now, when we get to things that are like a bit more, you know, outside of the world of like broadly accepted standards like PDF, we're in like the world of where actually things have lots of specifications. You know, you have prose standards or PowerPoint decks. I have read a large number of PowerPoint decks that are system specifications. There's the code. The fact that you're laughing shows like you do not live my life. So the reference implementations, inline code comments, blah, 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 blah. User stories, like in agile development, a user story is a description of what the system should do. It's a specification. And scribble notes on coffee shop napkins. I think we've all been there. These are not mathematically clean or stable over time or agreed by all users of the system or easy to reason about. And so that means that coming up with a coherent description of what the system should do is really very challenging. So here's a conversation we often have, right? You say, oh, hey, do you have a specification for your system? And it's, you're talking about like, I don't know, like some high assurance thing or some important thing, and it's got like hundreds of thousands of lines of code, and the person says, oh yeah, here's our 2-slide PowerPoint deck or whatever, right? Or here's a 7,000-page requirements document written in unstructured prose, right? And in both those cases, it's very difficult to see how you get to something that is even beginning to be like a formal specification we can do more formal methods on. This also leads to this conversation. We often have this conversation where, we found your system does X, but the specification says Y. And then the client says, oh yeah, that doesn't matter. Yeah, and you have that conversation 40,000 times because basically the specification isn't a description of what isn't normative, it isn't precise, it's just a thinking tool that they use to understand the system enough to kind of build it. So, some more instances of this problem. It's very hard to get engineers to write specifications. Like, again, for sort of like shallow and deep reasons, we're finding that it's very hard to learn a new spec language. That's just sort of a trivial thing in a sense. But like precise specification itself is a difficult skill, and specifications often require a deeper knowledge of the system than an engineer has or in fact needs. And specifying the environment is very difficult. Specifications for common libraries and world model is very hard. Kind of specifying the C standard library is a thing where there's several different versions of it. But like world modeling is another very difficult problem in specification because you need to sort of specify your assumptions. I think another thing that we've run into when we've been trying to do these formal methods projects is it's very hard to define and explain success. Like it's very hard to sort of basically say, what do you get when you do one of these projects, right? Why is it useful to you? Now, the typical shape of a formal methods project is you have a highly precise technical meaning for the thing that you proved. I forgot to mention like some trusted code base, trusted computing base as well. But it's difficult to capture as a simple explanation. So, like SEL4, I have an intuitive understanding that it has a separation property, but that's actually captured as a big Isabelle file somewhere, which you can read, but loading it in your brain is very, very hard. And the clients that you're working with probably can't read that theorem, because I have to sit down for a long time to read the theorem. So let's try to create some hard problems, like how does the client know they're getting something that they want? Like how do we explain what we're doing to the client in the way that they actually understand? And how do we know we're done? Like how do we know that the project even succeeded? Like how do we, in the worst case, how do we agree that we succeeded or failed if the client disagrees with us about that? So here's a bad version of what you can do, which I do not recommend. So you say, okay, we finished and we proved the theorem, and then the client says, great, what does that mean for me? And then you say, there are no more bugs in your system, good news. I do not think this is a good idea, because what will happen is that you have then 3 months later, your client comes back and says, we found a horrible bug in our system. And you sort of say, oh, well, that wasn't covered by the specification or originates in some other module, quibble, quibble, quibble. And this is not satisfying because they paid for assurance and you didn't explain to them the limitations. Or you didn't make sure they understood it. A slightly better version, which is at least kind of intellectually somewhat honest, is you say, oh, to simplify it means dense math theorem, right? And then you explain that. Now, this also doesn't help that much, but at least kind of you're saying something that's true. But it's like, now, again, like they're probably not going to be very happy if 3 months later they have the horrible bug and you say, okay, well, this dense math theorem, if you see disjunct 57, you see, in fact, this was always a possibility. Well, then that's not going to be very satisfying either. The approach we have taken, which I don't also find very satisfying, is we write big prose documents and we just explain this stuff. So you go like, hey, to simplify it means long prose documents. Caveat 1, caveat 2, and then you have a long discussion where basically you sort of say what A and B and C and D means. And this is like, so an example of this is his document we wrote with Amazon on the AWS LC verification. And so, this is like a big table, which is on the top front page of their Git repository, which just says like a bunch of, I think there's probably like 30 or 40 different caveats, something like that. But even here, it's a very high level description. So it's something where you need to have a lot of technical context before you understand what any of these caveats mean. So we went through many iterations trying to get that right. So it's sort of not ideal for several reasons. You know, this sort of stuff is expensive. It depends on technical clients, lots of discussion, hard for the internal team to explain to anybody what they're actually doing, even if they succeed. And the caveats tend to get smoothed off in a funny way. Like what happens is like we say carefully caveated thing, like the engineers understand slightly less caveated thing, the CTO understands even less caveated thing, and then the PR team says there are no bugs in the system, and then we're sort of back to the same problem. So we need to be very careful about what we actually tell people we're doing. Another related problem, oh yeah, go ahead.
Can I just ask, how does this interact with when you're attempting to sell them easier compliance?
Well, I mean, compliance in some sense is like, you know, the job is, well, I should say we don't sell like compliance things. You know, that's a thing that we have looked at, but it's a difficult space to be in. I think that like the compliance thing is different because in some sense like compliance isn't about security, right? You know, so because something passes the kind of security compliance, it doesn't mean there are no security flaws. It sort of aggressively doesn't mean that, in that sometimes those compliance processes don't do anything useful or they're actively harmful. And so like if you can persuade the regulator to pass you, that's more the bar of success there. So it's sort of a different thing, but it isn't, again, very unsatisfying to do things which, you know, are kind of performatively kind of like helping with security, but are not actually doing that. So that's not a thing that we do, but it's sort of a different, more measurable success criteria. Okay, I've only got 10 minutes left, so I'm going to move on. The last thing I think is that kind of we really have to think about is like often you want to do the cheap thing first, right? So there's some landscape of, you know, assurance things you can do. And this is just in general in software engineering. And so, you know, if you haven't done, you know, if you can do code reviews and documentation, and this does a lot to increase the reliability of your system. You can do testing, like the bad old dumb kind of testing. You can do continuous integration. Then maybe you can do something that's more in our kind of realm, fuzzing, property-based testing, model checking, and then you kind of get up to things that are more like proof. And so, you know, as you increase your efforts, you increase your confidence in the system. And this is a very effective way to increase your confidence over time. So you can kind of step down this ladder, and as you do more of this stuff, you get more reliability. But it's worth pointing out that like out there in the wild west of software, many systems do not do these things right at the top here, right? Like many systems don't really have sufficient code review or documentation. Many systems don't have very comprehensive tests. Many systems don't do CI/CD in a very sensible way. I mean, I should say that like there are plenty of Galois projects where we don't really have CI set up in a way that I would like. And that sort of presents a challenge when you're saying to somebody, hey, you should do like a formal method. Because if you've got like project number 1, which is write more tests, and you've got project number 2, which is do a formal method, then the one that is kind of, you know, low cost, low benefit might be more cheaper and more predictable and more attractive than doing the formal methods. So I sort of feel like that's sometimes the thing we run into. Like I think Dan Guido from Trail of Bits told the story at some point on some, I think it was on a podcast where basically, you know, some cryptocurrency they were working with, and they said, you know, hey, you know, he said, have you got any tests? And they said no. And he said, well, okay, you should just write a test, right? So like it's, you know, that's often a good piece of advice. Write one more test. That's actually a useful thing to do. So I think that there's like kind of 2 ways you can think about this from a formal methods sales pitch point of view. You can sort of say, well, formal methods should be applied after these conventional techniques. This approach makes sense. I think it describes a lot of formal methods projects right now, but it really limits the number of projects that pencil out. Because, you know, there's plenty of situations where actually what's going on is the thing that you should do is write one more test. Formal methods should replace conventional techniques. This sounds great. I really think it's mostly not true now. I think that there's some domain-specific things like Tyros and Zelkova at AWS, where they do the solving, they do sort of this SAT solving as a replacement for kind of pervasive testing. And so in that case, I think it does make sense. But it would be kind of make these kind of tools vastly more attractive and from vastly more kinds of projects if we could really say, in some legitimate, grounded way, like this is better than testing, right? And in every regard. But it's very rare that that's actually a thing that we feel like we can legitimately say. So here are some of my super hot takes. I should have added the slide here where I say I love formal methods, and I think that it's a really great thing to do. I think that the theme here is cost and benefits. So let's say you've got your favorite underappreciated formal method. So let's say Galois builds a tool called SAW, which I think is a very good tool, which is underappreciated, as many tools are. Well, if we want to make it more viable to do projects, then there are I think that there are sort of two levers we can pull. We can make it cheaper, or we can make it more beneficial. And that can pull it across the line into the land above this kind of break-even line. So more projects start to make sense. I think maybe a final sort of super hot take. I sort of feel like maybe this kind of beneficialness is a more easy thing to kind of change, because I think that just a lot of this is about orientation to client problems and figuring out what people legitimately want. And so maybe there's more we can do in this regard. I think that the other axis, I think, is really important. But I also think that there's just been a lot of work to try and make formal methods cheaper, and there is a core of difficulty in a lot of kinds of formal methods projects, and so it just seems more challenging, but it's very important here. Yeah, go ahead.
When you say be more beneficial, do you have anything in mind with this? Do you mean verifying new kinds of properties, or
do you have any examples that you might be able to give?
I think. This is sort of this is the most low confidence kind of claim in this talk, I suppose. I suppose what I mean is I think there's quite a lot of space for building people figuring out more what people actually want, sort of orienting more towards domains where people care about things. And one example is this kind of regulatory compliance thing, where are there ways that we could find use cases where there's a lot of kind of existing costs, and if you can eliminate things that are already kind of very costly, then that's a place that you can have a lot of value, even if the tool doesn't get any cheaper. But yeah, I think this is more a gut sense, I suppose, than sort of high confidence. All right, thank you very much.
So you talked about going to the customer and saying, your documentation, your specification says X, your code does Y, and then getting answers. Now, one answer that I have got far more often than I might expect is, oh yes, we changed that. And that's one lesson, right? The documentation is always out of date. Is that a place where some automation might help in keeping documentation up to date?
Yeah, and this is where I'll utter the cursed phrase large language models, because I think that I do think that there's the idea of extraction of properties or kind of consistency checking or something where you could I think this is another pain point for a lot of teams. They have documentation, they do want to know what their code does. If you could find a way to kind of sort of yank some model out of code and then kind of from the prose documentation build another model and then do comparison between those two things and do some sort of reconciliation between them which the users can make sense of. That feels like a place where there's a lot of potentially interesting work to do. And yeah, that's a great point. I think that it's, when you get those PowerPoint slides, often what that describes is version 1 of the code. And then since then it's evolved and all the real documentation is in the heads of the people who are on the team.
And it's evolved for good reasons.
Yeah, it's it's more secure, it's more scalable, blah blah blah. They've done things that made it better, but there's no kind of ground truth thing that you can point to that describes what that should be doing.
And so then what about something like ASL, where there really is a sense of the specification being a ground truth, and you do go back to that ground truth. You're probably delayed sometimes, but you do try.
I mean, I think that I think that having DSLs that you can use as a sort of, you kind of use them as both spec and kind of like code, I think is really good. But I think that, I'm not the first person to observe this, but unless the kind of that artifact, that model or whatever it is, like does some work for you, it's very hard to keep it maintained. And so I think that, repositories are full of kind of people who built CLA plus models or kind of other kinds of models. And so I think that the question is just sort of what is the motivation for the team to kind of keep the model correct? Like it might, I think it's in some sense, like a good thing is if you can do synthesis from a higher level thing into like a lower level representation, or if you can use that as the origin of your test suite, because that means also you're motivated to keep your model accurate, because then you detect discrepancies. But when you've just sort of like, you check the model into the repository and then you sort of pat each other on the back, then probably 6 months later, no one has time to update it when the system changes. It takes a lot of discipline to do that, and most teams, well, it takes resources to do that, and teams don't typically have that. So I think it's really valuable if it can be made to work, but it really depends on workflow considerations.
Shank, obviously.
Yeah, Mike, appreciate the view from the trenches. I actually just answered one of the questions I had, but I want to point out that there is a very interesting book that I don't know if many of you have had a chance to come across, called Mechanizing Mathematics by Donald McKenzie. How many of you have seen this book? Warren, by the way, is an important character in the book. So this is, I think it amplifies on many of the themes that you read. It's a wonderful read. It's a page-turn idea.
Okay, yeah, I'll check it out.
And, well, yeah.
So, in my efforts to try to formalize a few things in a corporate setting, it's often the best thing that we do is make their process more rigorous. In other words, just reading, the first thing I ask them for is an ASCII dump of all their documentation. And that's sometimes they fail right then. And the more that you can mechanize their process, a lot of times they're already happy. Because you've already improved their lot in life so much that getting to a formal method is sort of beyond. And I know that I have terminated a number of my relationships with them, just because they were already moving on, because that was enough help that it takes them some time to internalize that and make use of it. But when they get that down pretty well, then they often will come back. And what's the, like it's sort of like, what's the next level? It's like a game or something, And so, but anyway, I mean, that's not a formal method. It's just capturing their content in some kind of reliable way, mechanically, is a very revealing effort.
Yeah, and I wish that there was more, I wish there was more kind of software process research about kind of, one problem is, I think that there's like a temptation to go to the most, hardcore tool first. I mean, I feel that as well. I'm like, okay, what you need is the most powerful tool. But in one way, I think that like having a software, like having a process where you say, hey, you should build software this way, and you should have like rigorous documentation, or you should build tools that help you to build those things, and then sort of like creeping up to the problem of doing more formal methods. Like I think it would be really good if, there were popular tools like, Rust, for example, which help formal methods while also being popular for other reasons. And I think that's kind of part of what you're saying. Like it's valuable to the engineers who don't have to care what a theorem is. But then later on, they're like, oh, hey, you know what? Some more theorems would be good. And we're in a great position to do that kind of work at that point. Whereas it's very, like current tools are not set up in that way. So I think if we can sort of creep towards, or sort of sneakily do useful things that then set us up to doing more advanced things, that is a very rich space to be in, I think.
Sure.
So in academia, right, we're very good at coming up with these very technical things, but then we're not so good at conveying sort of even what we've achieved, let alone the value of it. And often the people who end up doing formal methods with industry or with government, were trained by us. And so they sort of inherit this difficulty in even explaining what your verification does. And I feel like there ought to be some space to sort of look at the let's say, the rhetorics of or the conveying what is achieved. And I get the impression that sort of Galois is in a privileged position because you see lots of clients and over again, and you see attempts at explaining, I mean your own attempts at explaining what is achievable with different things. Have you thought about sort of retrospecting on that process to see how do we explain the value of this approach? How do we convey the what this can even do?
Yeah, we do quite a lot of that, and I don't know that it's captured at all right. I think for me it's just been, I try to talk about things in different ways, but I mean, I think that one thing that I really admire Peter O'Hearn and Byron Cook is that one of the things I really admire about them is that they're really good at sort of crisply kind of coming up with descriptions of things, like complicated things. They come up with things that are both kind of good pieces of kind of rhetoric and also kind of authentic descriptions of things that they're doing. And I think that having those are kind of gold dust, really. They're kind of, even like a good name for something. I think that, like I think having a sort of, having a good way to sort of talk about like a property. I think that, I think Rust, again, keep on mentioning Rust, but like Rust is good in that it's conceptually pausable by engineers who don't care about formal methods, but also we can make sense of it, and so there's kind of a meeting point between us. But yeah, like plenty of useful stuff to do in that space, I think.
Okay, Sam, and then Michael, and then we're stopping unless people are bursting for something. So Sam first.
So not technical, but like, what sort of people do you hire? This is not me doing a recruitment drive. Like, what sort of people do you hire, and like, how do you actually keep them? Because I feel like if you just go and hire a bunch of like really clever formal methods people, they're just going to want to desperately drive towards the like high cost, really hard things to do. So how do you like stop them just changing around?
Well, we tend to hire. We do hire a lot of formal methods PhDs, and I mean, I don't want to give the impression we don't do the sort of hardcore stuff as well. Like, I mean, there's a big mix. Like, this is more talking about the more kind of small engagement commercial end of what Galois does. We also do these big collaborations like the CN work, which is much more academically spirited. I think that I think the appeal of being at Galois, for what it's worth, is the opportunity to be a little more applied and sort of to build a little bigger, and to, I mean, the aspiration is to try and like do stuff which kind of impacts the world a bit more. We don't always succeed, but that's like a good thing to do. It's like, and I mean, it's I think actually that a lot of people, what I found is, so I was like pretty deep into theory land when I moved to Galois, and I found that going to Galois was actually very interesting because I think I was like initially like, oh God, what if they make me work on something I don't care about? And then I got pulled into this stuff about parsing, which is like totally the domain I don't care about. And what you find is actually that like having clients really sort of sharpens the edge of the blade, because you don't just care about what you care about, you have to care about what someone else cares about. And I think that's the real opportunity, is to kind of, have to like have someone tell you you're wrong quite a lot, and then you're like, maybe you get more right. That's useful.
And just to say also, so when I visited Galois, I was very surprised at, there's the tool developers and there's the users of the tools. And sometimes they're the same person, but quite often they're separate, and they made quite a thing to get to these different styles of people. And certainly in many academic teams, you get the tool developer rather than the user. And so maybe this is changing with all this DARPA work, and because the tools are mature.
Yeah, what you said was reminding me of something of what like Byron Cook said, like at the PLDI, like this year he had a very interesting talk, and one thing he mentioned there, which I had not heard before, was that like when you often talk with developers, it's sometimes hard to sell like formal verification to like developers directly, because they think, okay, they wrote the code, it's correct, and they're like, if you tell them the code is correct, they're like, okay, it doesn't help me so much, and they get more interested with bugs. But like he said, that when you talk with management, this becomes different, because management really likes to have like concrete statements they can trust about their code. And I was wondering whether this is your experience as well, whether like talking to like development and management like is different for like selling formal methods, or how you think about it.
Yeah, I think this relates to something we've been talking about a lot, which is, I think that, sort of in one way, I think actually my experience is the engineering teams are usually really excited to do something different. But the correct unit of decision making for the project is actually the organization. And so, in some sense, we've sometimes had these conversations where the developers are really excited and the management doesn't care, and then, well, the project doesn't happen because they don't have decision authority. And so, I think there is a different set of priorities. Like the management is trying to, if things are working, the management is trying to kind of make economically valuable decisions. And so, in some sense, like if the developers are keen, that doesn't matter, right? It doesn't, and by the way, I think this also means that, if a tool is kind of ugly and annoying and makes the developers miserable, well, that's bad, but it doesn't really affect the decision to use it or not, except in as much as it affects their ability to kind of like execute on the task and for them to hire into that team. So there's kind of a really different kind of, I think it's a bad idea, you need to keep clear in your mind what audience you are trying to address with the solution you're giving, and then focus on the things that delivering value, reducing costs from the perspective of that group of people, whoever they are. So yeah, I think it's really hard to figure that out sometimes, but it's definitely necessary.
Are we done? Let's take like